In this video, we'll cover how to add a log transform to your dataset in MyCurveFit.com and the MyCurveFit Excel Add-In. The content in this video will focus on a log 10x transform, but this technique can apply to log 10, log 2, log E, and also y-axis transforms. Let's start in MyCurveFit.com. I have an example dataset with X and Y calibrators entered and a 4PL fit applied to the data. Looking at the X calibrator data, we can see that it spans multiple orders of magnitude. And reviewing the curve chart, it's apparent that this is not a very good fit. The fit line doesn't follow the calibrators, and the R-squared value is low. For some datasets, especially for datasets where the X values span multiple orders of magnitude, it's recommended to add a log 10x transform to the data. This can greatly improve the fit. Note that applying a log 10x transform is not the same as plotting the data on a logarithmic x-axis. Selecting the x-axis settings and changing the axis to logarithmic only updates the view and does not improve the fit. To update the X data transform in MyCurveFit.com, I'll simply open the advanced settings and select the log 10x transform. You'll see the curve chart is automatically updated for us, showing an improved fit with a higher R-squared value. This is pretty simple to configure in MyCurveFit.com. However, to perform the same data transform in the MyCurveFit Excel Add-In, you'll need to configure the steps within Excel. I have open an example Excel spreadsheet with my same X and Y calibrators, 4PL fit parameters calculated, and a curve chart showing my fit in blue and calibrators in orange. Reviewing the fit parameters and goodness measures, we can see the R-squared is not very high, at 0.755, and the fit chart also demonstrates that the fit line does not model the calibrator data well. To apply the log 10x transform in Excel, I'll first compute the log 10 values of the X calibrators in this table below our original data. I'll enter equals log 10 and select the corresponding X value from the table above. I can then drag this formula down to fill the remainder of the calibrator table. The Y values will remain the same, so I'll just copy and paste those values down. Next, I'll calculate the 4PL parameters by entering equals MyCurveFit and selecting the 4PL option. I'll highlight the log 10x calibrators, followed by the corresponding Y calibrators. And in this example, I'd like my parameters to appear vertically, so I'll enter a 1 into the orientation setting. Pressing Enter calculates the 4PL parameters and our goodness measures. You can see right away that the R-squared is much higher, 0.999, compared to 0.755. And my curve chart appearing to the right-hand side of my parameters shows a fit line that more closely models the calibrator data. I've created this curve chart using a logarithmic plot data table. For more information on how to create this chart, please see the associated video. What if we were applying this transform to a dataset being used to back-calculate X values? For example, calculating concentration values in an assay such as an ELISA. How would we calculate those concentration values? Below our chart, I have 3 samples with collected Y values, in this case, absorbance data. I'd like to use the log 10x transformed curve fit parameters to back-calculate their concentration values. To do this, I'll first calculate the log X. I'll enter equals MyCurveFit and select the 4PL Calc X option. I'll highlight my fit parameters and press F4 to denote these as an absolute reference. Next, I'll highlight the corresponding Y value. Pressing Enter applies the formula, and now I can drag down to fill my remaining samples. To return the concentration values, I'll need to now take the antilog of the log X values. In the concentration column, I'll enter equals power 10, and select the log X value. Dragging this formula down returns the calculated concentration values for the originally entered Y values. If you have any questions about how to apply a log 10x transform to your data, please email us at support@myassays.com.